what's defining our bands. There's some darker bands, some lighter bands. What do you think is defining those qualities? Sand, clay. Clay tends to be a bit lighter and finer. There's some really dark layers. What's defining those?
Basaltic ash.
This is the basaltic ash. Maybe some dust as well. And so we're seeing grain size differences as well on top of these material differences. So we've got the materials of cinder and ash. We've got the grain size differences of muds. Muds are tiny, they're mixtures of silts and clay, and sands that are characterizing our deposits. Now the other thing that I think is really impressive about this site, and we can see it on the other wall too, is that in places we have really nicely rippled deposits. So if you look at this surface here, look how wavy it is. And off in this direction, thank you. Look at that texture. Is that stratigraphically right, or do I have it upside down? I think that's right. That was up. Look at the waves that move through this. How might waves like that form in sediment?
Position it was in when it cooled, or no, it's not cooling.
Yeah, this is sediment. This is sediment transport, isn't it?
It's covered.
So what moves sediment?
Water.
Water, wind, ice, gravity. Does gravity make wavy scenes in a landslide deposit?
No.
Turns out ice movement doesn't do this either, so now we're down to wind or water. Okay. And they both make ripples, don't they? And so we're to a point where we got to decide a little bit, is this water transport or is this wind transport? As far as the sedimentary, these are known as sedimentary structures. There's lots of different sedimentary structures. But one example of a sedimentary structure is ripple marks. These are preserved ripple marks, fossil ripples, preserved in stone. And we've got a whole rippled section through here, okay? And that entire rippled section moves right along this level right here. And so one of the things that we might start trying to figure out, whether or not this is wind or water, is start evaluating the material above and below. Now the material above and below is very finely layered. Nice thin, probably mostly siltstones, very thin layers. To collect layers like that, you need a really low energy system as these fine materials collect and settle out of that system. And as soon as I start saying that, that doesn't really sound like the wind, does it? So that suggests maybe standing water. Standing water, collecting silts and clays, those settling out, forming these really fine layers, collecting down here about knee level with Elizabeth there. And then that water gets moving. And one of the best indicators of the movement is actually associated with ash and cinder rich layer. It's this darkest layer right here. You can see it down here pretty well, that layer right there. And what I want you to notice in this is that we've got class set up in that orientation. See that orientation right there? And that's inside this layer, below the ripples themselves. That orientation is describing cross-bedding. And cross-bedding indicates current, and our class sizes in here become at least pinky nail sized. I've got a little piece right there. You can see that that's that large. Wind doesn't move stuff that big. So just looking at that cross-bedding right there is telling we've got a water deposit. And the initial flux through here was moving coarse material, stuff as big as my pinky nail. And then that movement began to fine, so the energy began to diminish. And through these nice cross-beds, we fade into ripples, and then we fade back into the fine layers, suggesting again, standing, quiet water. So that layer succession, just right through there, is giving us a history already about quiet water deposition and the settling out of finer sediment, with the infusion of current and movement of cinders and basaltic ash developing these crossbeds, and then that energy begins to fade into the ripples, only to be capped again by fine layers associated with quiet standing waters.
Does that indicate like a flood or a large
This
water
could be
event?
a seasonal event. This could be associated with the blocking of the drainage and then the unblocking of the drainage, only to have the drainage system blocked again. That's a possibility.
If the fault raised up and provided a little more energy to the water,
Yes,
and then it cut its way down again too.
absolutely. Part of tectonics and part of our story here, and we'll see this as we go further into the field area, is that as tectonics, as the faulting creates topography, it invigorates river systems where it doesn't block those river systems. And so that rejuvenation of a river system is manifested in a coarser influx of sediment. Pebbles, cobbles, boulders, gravels of that nature. You'll see that a little bit later on. In this leg of the system, if it's all part of the same system, and that's an assumption, if this leg of the system right here, it's showing invigoration in that scene, and it really could be to topographic changes, elevational changes associated with faulting. It could also be landsliding off a landscape produced by a fault system. And there are other things that could potentially restrict the movement of that water and back up the water and reduce its velocities and make it pond, basically. And we'll see some of that a little bit later on too. Okay. One of the neat things that you can do at this site as well, because there's an overhang here, is you can measure the direction that the water used to flow. Okay. And so those crossbeds form downstream. So these are actually bed forms in a moving channel of water. So if the water is moving this way, it'll pile up sand, which then avalanches down the front of a ripple, only to push sand up that ripple crest. It avalanches down the other side. And so the crossbeds, they get preserved in this orientation, telling you water's flowing that way. So those crossbeds, what direction are they telling me?
Right there, it looks like it's toward the west.
Yeah, towards the bus, which works really well for our assumption. If that assumption is valid, and I'm not confident that it is, it's something that could be field tested. But those crossbeds are suggesting flow in this direction. We actually took a bunch of flow indicators about a year ago up here, and the flow indicators are all southwest to west in these outcrops through here. That actually kind of fits with a little bit of the modern drainage pattern, which is out of the east with the Pitt River and moving to the west. So a southwest-west pattern is rather consistent with that whole story. So this begins this part of sedimentological responses to landscape evolution. And the landscape evolution in this area is driven by volcanism and driven by faulting, part of that big tectonic scene. And we'll revisit more of this at the upcoming stops. We'll see how other parts of this valley system responded. In fact, we'll do that right around our lunch stop. One more time, two more times as the day progresses. Questions about this at all? I got a couple of 3x5 cards that arrived, and we'll see if we can address those on our drive to lunch. I do still have those 3x5 cards up front, so if there's anything that's popping into your mind, grab a couple of those cards, and we'll see if we can talk about them in transit.